Okay, so let's say you are running a service and everything is fine. A few users requests coming in, the server handles them. Everyone is happy. And then one single client goes haywire. Maybe it's a bug, a loop that forgot to stop. Maybe it's a bot. And it starts firing requests at you as fast as it possibly can. Thousands a second. And here is what happens that one server can only do so much work at a time. So the extra requests start piling up in a queue. Remember from the latency video? That queue is exactly what makes everything slow. The server chokes. And now, this is the important part. Every other user, the normal ones, they start getting errors and timeouts too. One caller who maybe did not even meant to just took down the whole service for everybody. So the question is simple. How do you stop one caller from breaking it for everyone? And the answer is a thing that almost every real service has, quietly sitting out front. It is called rate limiting. Let's build it up what it actually is. So at high level, rate limiting is just a cap. How many requests one caller is allowed to make in some window of time, like 100 requests per minute per user. And the way we enforce it is we put a little gate in front of our service that counts each caller's request under the limit. Go through, no problem. Over it, the gate just refuses the extra ones. It does not even bother doing the work. And here is the first thing to get right because a lot of people picture this completely wrong. Rate limiting is not a ban. A ban says go away forever. And a rate limit says not so fast. You are going a bit too quick right now. Try again in a moment. It is temporary and it is per caller. So do not think of it as a wall that locks people out. Think of it like a toll gate on a highway. It does not stop you, it just controls the flow, letting cars through at steady pace. Come too fast and you just wait a moment in the queue. That is the whole idea, right there. And when the gate does not turn you away, it is polite about it. It sends back a specific title code. You saw these in the HTTP video. 200 means here you go, 404 means not found. Well, this one is 429. Just means too many requests. So anytime an app tells you 429, that is just the toll gate saying slow down, come back in a bit. Okay, so why does every real service do this? Think back to that server melting down because of one caller. A rate limit heads that off and it buys you a few things at once. The big one is protection. You keep the service up even when one caller goes crazy or an attacker shows up. And right behind it, fairness. No single user gets to hog everything and starve everyone else, right? And then two more that really add up. Cost. If each request costs you money, say it hits a database or some paid API, then a runaway caller is running up your bill. And a limit caps that. And abuse. It slows down bots, scraping, and people trying to brute force a login by guessing a million passwords. So protect the thing. Keep it fair. That is the heart of why. And here is the thing a lot of beginners think wait, if my server is getting overwhelmed, can't I just add more servers? And honestly, for this, no. Look, adding more servers is exactly right when it is real growth, genuine users. But you cannot scale your way out of abuse. Think about it. If someone is flooding you with a junk request, then paying for more servers to handle that junk is just paying more to lose. And adding server never fixes fairness anyway. One greedy caller can still hog whatever you add. So, rate limiting is about what gets to use your capacity. It is not the same problem as how much capacity you have. That is why you need it as well. So, how does the gate actually decide? Now, there are actually several different ways to build this gate, and comparing them all is a whole topic on its own. I have got a full deep dive on that if you ever want it. But for today, let me show you just the one that is the easiest to picture, and honestly, one of the most common ones out there. It is called the token bucket. And remember that so many per minute cap from a moment ago, that is just how you actually enforce it smoothly. So imagine literally a bucket that holds tokens and tokens drip into it at steady rate. Let's say two tokens every second. Now, every request that comes in has to grab one token to get through. Token in the bucket. Take it. Go through. Bucket is empty. No token. Refused. 4 to 9. And the clever part, there are actually two numbers there, and they do two very different jobs. The refill rate, the 2 per second, that is your sustained pace, the average rate you are allowing over time, and the bucket size, how many tokens it can hold at most. Let's say 10, that is how big a burst you allow. So, two separate knobs. One sets the long run pace, the other sets how much of a sudden spike you can absorb. Most people think a rate limit is one number. It is usually these two. And why is that actually nice? Because real traffic is never perfectly smooth. So let us say a user has been quiet for a few seconds. The bucket fills back to its max, 10 tokens. Now they can fire 10 requests instantly, a little burst, because they basically saved them up while they are idle. And then bucket empty. They drop back down to the steady 2 per second. So the bucket is saying, sure, burst a bit if you have been calm, but over time stay around this pace. And that matches how people actually use things. That is how you set the pace. So that is the whole mechanism. Now, one important detail, and it is a nice one. This bucket is per caller, not one big shared bucket for the whole world. Every user, every app that talks to you gets their own bucket. So my runaway loop drains my bucket and throttles me, and it does not touch you at all. My mess is my problem, not yours. Now, one quick thing on who counts as a caller. The clean way is a logged in user or an API key. Just a little ID a service hands you your app so it recognizes you. You can also use the IP address, the network address a request comes from. But honestly, that one gets messy because a whole office can sit behind a single IP. So use the strongest identity you have got. And where does this gate actually live? Usually right at the front door, at the edge, or an API gateway, which is just a checkpoint that sits in front of your real servers. And that placement is deliberate. You want to reject the extra request as cheaply as possible before they even reach your servers and start doing expensive work. The earlier you can say no, not yet, the less it costs you, right? So reject early wherever you can. Okay, now let's flip it around because you will not only be the one doing the limiting, you will also be the one on the other side calling somebody else's API and getting limited yourself. So, what happens? You send too many requests and you get back that 429. And a good API does not just say no, it usually tells you what to do next. It often sends back a little header called retry-after, which basically says wait for at least 5 seconds before you try again. And the right thing to do when you get a 429 is back off, wait, and then try again. What you should not do is immediately hammer it, retry, as fast as you can. That just wastes everyone's effort. And honestly, it starts to look like an attack. So, wait for that retry after. And if you keep getting limited, back off more each time. Wait 1 second, then two, then four. And the really well behaved clients watch how many they have left and slow down before they hit zero. Because a 429 does not mean something is broken. It means the system is doing its job on purpose, protecting itself. Treat it like a slow down sign, not a red light. Okay, let's put it together. Rate limiting in three words: protect, pace, retry. You protect the service and keep it fair, so one caller can never take everyone down. You set a pace with something like a token bucket, a steady refill for the average, a bucket size for the burst. And when someone goes over, you tell them to retry in a bit. That's the 429. That is the whole thing. And just so you know the edges of it, this is not banning someone, it is temporary. It is also not quite the same as limiting how many requests can run at once. That is a slightly different tool. And on its own, a rate limit will not stop a really big spread out attack. That needs more than this. But for the everyday, one caller should not be able to break it for everyone. This is exactly the thing. Now, I have shown you one way to build the gate, the token bucket, because it is the easiest to picture. But there is a whole family of this, different algorithms, and it gets genuinely tricky the moment you have many servers all sharing one count. If you want to go deep on which one to pick and how it holds up at scale, we have got a full deep dive on exactly that. But for today, remember one picture. A rate limiter is not a wall, it is a toll gate. It does not say no, it says not so fast. See you in the next one.